Okay, quickly we're looking at quantities that looks invisible in mathematics. What quantities looks invisible as though they don't appear but they are relatively there in mathematics? Number one is decimal point. Decimal point. Okay, which area in mathematics? Example, I can give you that's whole numbers. In whole numbers, people think that decimal point does not relatively appear. If I give you an whole number such as 1, my decimal point is immediately after the whole number. That's 1 point, whatever, 1.000. And that decimal point is, or another whole number is 24. Where is my decimal point here? My decimal point is what? Here. So I can write as many zeros as possible. This is still 24. Okay, that is number one. Another example is I can use 136 or 248. My decimal point is where? At the end of the last whole number there. Okay, so that's whole numbers. Then the second thing that looks invisible in mathematics is 1, the appearance of 1. The first area where 1 appears invisible is as a coefficient. I'll be using one example in this area. Example, x. Now, when I say you find the coefficient of x, you might tend not to know what it is. It is 1. Why? Because coefficient means what number multiplies that variable. And what multiplies x invisibly here is what? Is 1. The second aspect is as a power. As a power. What is a power? Index. What is index? Indices, basically, isn't it? So, as a power, example is still x. What is the power of x in this place? It's 1. X raised to power 1 is x. So, the 1 here relatively seems invisible. And finally, we have it as a fraction. As a fraction. That is x also. In which case, other areas where you see fraction can be 2 over 3, 4 over 5, 7 over 7, as a fraction, or we call it as a whole number also, where x here represents a whole number, and then it is like over 1. It is acceptable in mathematics. I can say x is the same thing as what? X over 1. So these are the areas where quantities look invisible in mathematics.